Okay, so this presentation, well, I kind of notify you beforehand. So next week we will have some other surprise arrangement for you, which you won't know what you are going to present before the class. Okay, we will have 8 topics for the next article. Yes.
Is it graded?
Well. Well, it's hard to say, right? Well, no, it's participation. I will do it. I will consider that in participation, but presentation itself is not a grade item. Okay. So yeah, and it's mainly for fun. So both the answers are correct. Yeah. Well, as I mentioned, those 2 articles, they're really good resources for you.
Yeah, that's very good.
Yes. Okay, so now let's, today we will have 5 topics, solid, those 5 topics. Now let's welcome the first group, S.
That's me?
Yeah. If you want to use the computer, please use my computer. So that.
I have to use yours? I can just hook up to the HDMI cord and projector real quick. You want me to?
Well, I want to stream this thing. So do you have a USB? USB, or you can send email to me or something like that. Yeah, if you have slides,
Yeah.
please use my computer to play that. Yes. So next week, yeah. Oh, okay. Let me finish about next week. So next week, 8 topics. We will do 4 on Monday, 4 on Wednesday. So in order to make sure you can present something there, and since you do not know which topic you'll be assigned to.
Next week is break.
I mean after we come back, yeah. Where am I? Since you don't know what topic you will be assigned to, right? So the safest way for you is to read the whole article. Okay, read the whole article, learn everything, and then prepare to focus on the topic you are assigned in the class.
Which article?
The next let me show you. For the week after, the week after Thanksgiving, we'll have another article. It's in D2L. It's the tutorial. Well, I forgot the whole title.
Best practices?
Yeah. Oh yeah, tutorial for the best practice.
It's in week 13. Not tomorrow.
Yeah. It's in week the last folder. Yeah, the latest folder.
I stole my daughter's thumb drive, so. Should be. Here we go. Oh. Ooh. There we go. Does that work?
Okay. Yeah.
Okay. So my name's Chris. I'll be presenting on the single responsibility principle. So you're probably wondering, what is it? So there's a big formal definition of it, but simply put, a class should have one and only one reason to change. So there's specific say a reason to change instead of one function, because then you could have a class explosion. And it also should be kind of tailored to whatever your business needs. So one example they gave was a car engine. Well, if my business needs to worry about the service of it, then I need to worry about the injectors, the pistons, everything in it. So then I would have a bunch of classes. But if I'm only worried about designing maybe like a car and a driving, then I should only have like a class for an engine. So I guess the detail of it depends on whatever your need is. So another example that they gave was an email application to send reports. And so what they chose to do is to break out each of the different types of files in which they can send, and it allowed it to be more extensible. And so if they wanted to add a scripting file or another type of file, it's very easy then to add it in. And so what changes in this is the type of file that can be sent. And so that's how they separated each of them. So what is the big deal of this? This allows us to encapsulate each class's responsibility within itself, and it makes it more extensible and easier to grow. Any questions?
So,
No.
one question?
Sure.
Questions, yes.
You're gonna get three.
If I want you to summarize the takeaway of this
Yeah.
idea, what would you say? Just a summarize.
Yeah, it's so it's kind of like in our design patterns class we talked about just separate everything that kind of changes. And so as we saw with the ducks and the types of quacks, you know, it's we did kind of the same thing, and that way it just makes the software more extensible, and it makes it where it's not as painful when you have to go in and make changes as well.
So why does it help you less painful making changes?
I mean, so you create something that has less coupling, and so, you know, where everything's kind of things in which would change or touch less things, I guess, if you'll say, and so therefore you create less bugs and you break less things when you make changes because you've kind of encapsulated that into one single location.
Yeah,
Something like that. But if you were up here, what would you answer that question
It
as?
has multiple responsibilities and has multiple reasons to change.
yeah.
Yeah, that's what I'm saying. Just not as eloquently. Okay?
Well, and this is like kind of connect with the rest of the topics.
Yes.
Because we have a single responsibility.
Yes.
And if some module has more responsibility there, may change something, you will have some unintended effects because too many things are dependent on each other,
Yeah.
and you don't know. Well, this code, this section of code, maybe not
Yeah.
correct for the function you are going to change right now, but it may work perfectly with
Yeah.
another function somehow. So, well, just an example of that. Yeah.
So it makes it less coupled.
Yes.
Yes.
Okay. Cool. Thank you. The second group.
You might need to run a virus scan after this. I stole this from my daughter, so who knows? I'm sorry.
Okay, then you can maybe do it here.
Okay, I'll start. Our topic was open-close principle, and the definition in software in object-oriented programming. The open-closed principle states software entities should be open for extension but closed for modification. So basically, we want our software to be easy to be extendable than changing things.
Which one?
Yeah.
Oh, is that? Oh. What the basic idea of open code principle is basically is you want to have a system that you want to use multiple times. You don't want it to be modified. So how do you want to use it? How do you want to increase the extensibility? Is that you want to create interfaces which attaches to multiple different things and creates uses. It has multiple uses in multiple cases. So one of the examples I like this. So this is a maybe I'm trying to give me promise for this, but this is a modular file, right? So this is the interface. These have some connectors in them. So this is a printer. So when I connect to this, it becomes a printer, right? Based on the interface, based on the logic of the interface and the logic of these two, connectivity of these two, I take it off. I attach this, which is a 360 camera, right? Again, the interface stays the same, but the functionality is extended now, right? So this is the battery anyway. So that's the general idea of having, with the entire solid system, the principle that the author is talking about is all about creating a sustainable a really good software, right? So this is one of the most, this is one of those principles which makes really good software. So one of the examples that the author gives out is about that same email sender, and it's like a is there a thing? Do we have like a marker? No.
I think we'll do that drawing.
Yeah. So the basic idea of what the author is trying to say is you have let's say a file reader, right? And it sends an email. Whatever's in the file, the message will, the email will send a message whatever's in the file. And you have an interface that reads from different file formats. File format reader. And in here, you will have an XML file format reader, or you can have a text file format reader. So this is the interface, but we have different things attaching to it, and this will basically, you can actually extend it to actually read from multiple different file types, and it's still going to give you the email. It's much more extensive. So that's the general idea of open and closed principle. So thank you.
Can you repeat again? What is open? What is closed?
Okay, open means it's open for extending and closed for modification. So you cannot modify this part. You can modify these, but you can't modify this. You can modify this.
It's not cannot modify. It's just.
I mean, it's not.
You can do anything, but it's better to do
Yes.
the extension with the interface. Right? So you extend the interface. Well, the example you give is really good, and also because that phone, it has only one interface. So when you actually put on one printer,
Yeah.
it becomes a printer. If we put on that 360
yeah.
camera, it becomes only a 360 camera, as well as 360 camera. So the printer and the camera and something, it can
Oh.
do something like that. So
In this case, that's what's happening, right? In this
yeah,
case,
in this case, it
Yes.
can read XML and TXT. It's not like I can only read
Ah.
XML this time, then I can only read
Yeah.
text.
I thought it was cool to show it.
Yeah, but this is a good example. Just if the phone has multiple interface.
Yeah.
Yeah.
Then it's gonna be just
So when you attach a printer, you also have another interface for the earbud, right?
Yeah.
Yeah. So it becomes a printer and iPod, something like that, right?
Exactly.
So that's for open for the extension. And if you can have an interface that's you can add more interface, it have more capability. So instead of I'm doing something in the phone to change something, so we just we extend
Yeah,
it.
I mean, the phone is not that good of an example in that case. It's good of an example in terms of interface being the same. In this case, the interface has to be the same, right? As far as I understand.
So the information, the file format that is email depends on the object that is passed to the file reader.
Yeah. So the file format has a checker, like can validate and the get message or something like that. So it's going to check if I can validate between all these that we have, all of the extensive things we have, or, we can, whether or not we can actually validate. That's what the, so if we can, then we just extract the message based on these things.
That's right. So for example, right now, if you want another reader for JSON file,
Yes.
okay, what you do is you make the file reader. You do not modify the existing master. Like you use the exact something like okay, modify the existing reader and add some judgment and say if this is XML, I'm do this. If this is text, I'm going to do this. We're not doing that. Instead, the existing functions we keep it there. Then we implement new interfaces. Some new functions there.
So these will implement this interface.
We implement the same interface, but we just create another subclass.
Like the duck, okay, flyable, crackable. Later on, if you want to say some other function now,
Yeah, but that's not
sweepable, okay, something like that. to another implementation, the interfaces. Okay, all right, thank you.
Thank you.
Thank you.
And next group, solid, S-O-L, L. L?
This, that's, yeah.
Hi everyone, my name is Aziz. I'm gonna talk about the scope substation principle. So what is it? It is an object inheritance from a base, class, interface, or other abstraction. Must be symmetrically substitutable for the original abstraction. We know that all squares are rectangles, but not all rectangles are squares. So what happens when we try to change the height or width of a square? The height and width must be the same to be a square. In other words, if S is a subtype of T, when object of type T in a program, maybe replace it with object of type S without altering any of the desirable properties of the program. Okay.
Okay, so if you're following Liskow's principles, then all functions that use pointers or references to base classes must be able to use objects of derived classes without even knowing it. So it should not have to be explicitly defined in your program. Also, the principle is considered a particular definition of a subtype relation, which is called strong behavioral subtyping. Lipscoff's principle also imposes some standard requirements on signatures that have been adopted in newer object-oriented programming languages. First, it is contravariance of method arguments in the subtype. Secondly, covariance of return types in the subtype. Also, no new exception should be thrown by methods of the subtype, except when those exceptions are themselves subtypes of exceptions thrown by the methods of the supertype, which might sound very complicated. Please don't ask any questions about it. Okay. The subtype must also meet the following conditions. So preconditions cannot be strengthened in a subtype. Postconditions cannot be weakened in a subtype. And invariance of the supertype must be preserved in the subtype. Finally, subtypes should obey, no wait, what is that? Yeah, subtypes should obey by the history constraints, which is objects are regarded as being modifiable only through their methods, which is basically encapsulation. I would say any questions, but you know. How was that?
I have a question.
Oh, okay.
Do you have a question?
Okay.
No, I have a question.
Okay.
Yeah.
Okay.
So I just want you to pick one of the the rules there and give a simple example. Maybe you just
Yes.
you read through all.
We actually have a very fun example that we found online, which was a picture of, first you have a real duck, and then you have a duck with batteries, right? And it said, what did it say? It said, if it quacks like a duck and swims like a duck, but need batteries, then you're probably not doing it right, or something like that. Right, because they're the same in many ways, but if you have a duck and then you create a subtype, which is a battery-driven duck, then you can't use the subtype or the object of the duck as replaceable for the supertype, and vice versa.
So which rule does that example violate?
Which rule?
Yeah, you just read through.
Oh.
Right?
That's a great question. Let's see. Yeah, it is. Let's see. Functions. It's the one you have, I think. Which one was it? The first one.
For square, understand?
Yeah, it's an object inheriting from a base class interface or other abstractions must be semantically substitutable for the original abstraction, which is this one is violating.
It fits the exam.
So right. So that's yeah, interesting example. This you have a duck, a real duck,
Uh-huh.
and the duck driven by this battery.
Right.
Yeah, that driven duck, battery-driven duck is a subclass.
Right.
And yeah, sometimes people just think, okay, they are ducks, so I'm just gonna.
Right, I'm
make
just gonna put
one
it in
of them
there.
a subclass.
Right.
But that doesn't, well, in real world it doesn't make sense, right? Because they're just only called duck, but they have nothing in common, just some of the behavior. But genetically they are not the same.
Right.
So when you are doing this kind of subtype and supertype, you need to consider more about these principles, following each of them, and think about if that's really necessary to make one of them a subtype of each other or
Right.
supertype of
Mhm.
another. So that's be careful about the subtype.
Mhm.
That's another way of saying maybe it's better to use if you just want extension of functionality,
Right.
use interface
Mhm.
instead
Right.
of the inheritance. And if you use inheritance, you need to think and think again if that's appropriate.
Mm.
Yep. Okay. Thank you.
Mhm.
Thank you.
Thank you.
LIDI. Yes.
Hello, my name is Vincent Ogono, and we are going to do a presentation on the interface aggregation principle. The interface aggregation principle says that a client, like is a calling class or module, should not be forced to depend on an interface that it doesn't need. Okay, if we have an interface that has multiple responsibilities, say multiple methods, and the class only needs one, in some instances it doesn't know which method to call first, or because it doesn't need one method, one of the methods to that class or client is unnecessary, it's not needed, and that opens up an avenue for introduction of bug in the system. So in essence, the interface aggregation principle says that if a subclass or a client doesn't need some of the methods or properties implemented by the interface, then what you need to do is to break that interface so that that client or subclass should only use or implement that interface that it needs. So it also ties down to the single responsibility principle.
Yes, to give an example of that, think about the previous example you saw from the open close principle, where you had your file reader, right? This file reader was responsible for sending out an email. You had an interface for your file reader that read, a particular format, which in the previous case, this was a XML or text, right? Now think about it. These are actually flat files. So they have a particular format, right? They but what if, what if your company came back to you and said, we really like that you created this file reader to be able to send these emails out, but we really need you to read, this one particular piece. That throw you a piece of paper and you'll look at it and you're like, you want me to read from a database, right? So now I got to read from, a database, and so like I got to extend this out. And you being the typical programmer, right? You're pretty lazy, so you want to immediately throw it into its interface. Well, the thing is that now, so you open this up and you go, plus read, database, right?
Yeah.
You add that. Well, what ends up happening is that now you're forcing XML and text to all of a sudden, now they have to implement reading a database, right? These classes. So really what you want to do is you got to create a whole new interface. You want to break this out, right? Break this functionality out to where now the file reader is actually going to include two interfaces. So now you got an database. So now this. So now your database class only has to implement its own interface, and now you're not forcing XML and text. You're not having to reopen these to implement something they don't even need. And if you need another example of that, you could, think about. Well, think about if you, like, say you had a door, right? You implemented an interface for like a door. So you have a class door. It can interface your door. It can open, close. You can even check, various, other attributes for it. Whatever simplicity case, maybe a Boolean check. Is the door open? If open, close, right? So like, well, what ends up happening if, in that particular case, you only have that interface to open, close, or check if open for your door. But now all of a sudden, if your door company comes to you and says, well, we want to add another door functionality, or another door class. This time, this one's an alarm door. So if it's open for too long, it rings an alarm. And now you got new functionality that if you include it into that door interface, well, now your regular door needs to implement it, but you don't want to force it. So now you have to have a situation where you have an alarm interface just for that new alarm door class. So you don't follow.
Any questions? Don't have to ask. But if you want.
I have to ask a very tough question.
Oh,
Right, bring it.
So what is the difference between this one and the open-close principle?
This one says that an interface should not have multiple responsibilities. So if that happens, then the subclasses that implement it will be forced to implement all the methods, even though they don't need them. So in the case of open-close, that's you can extend the functionality, but of that interface, but you don't want to make changes to it, to the superclass, right?
So okay. Let me summarize a little bit. Okay. So the worst case scenario, you put everything in the file reader, on the top. Okay. everything there. That's the worst case.
Yes.
And the better case is, okay, I'm gonna have a file reader interface, in which we can do XML, text file, okay, and those things. Okay, that's the better case. And then later on, when you have the better case, I have a file reader, I can read XML, text file, and database. That's a little bit better than you just have a one single file reader class without any interfaces, right? And now to this step, even better case is, okay, in the interface itself, I'm gonna make the interface itself have some single responsibility.
Yes.
Okay, like this file reader, I'm gonna read those files, and database reader, I'm gonna take care of database, because I don't want file reader to become also a database reader, something like that. So all this principle there,
Yeah,
interconnect.
very much,
Yes.
very much.
Yes. Okay, and the main idea behind them is pretty simple. Pretty simple. Okay. No other questions? Yeah, let's welcome the last group, and yeah, thank you for no. What is it? Picture. Oh, you are in white.
Oh, I can get it. Back up there.
Hi, how's it going? Our group will be talking about dependency inversion principle.
What's the name?
Dependency inversion principle. When it comes down to the definition, the general idea of this principle is as simple as it is important. High-level modules which provide complex logic should be easily usable and unaffected by changes in low-level modules. It provides utility features. In order to achieve this, you need to introduce an abstraction that decouples the high-level and low-level modules from each other. Dependency inversion principle consists of two parts. The first one is high-level. These modules should not depend on low-level modules, but both should depend on abstractions. And two, abstractions should not depend on details, but the details should depend on abstractions.
Right, so the important thing to note is that you're creating an abstraction from which both the high level and the low level modules can depend on. You're not reversing the dependencies, the direction of the dependencies. You're splitting it between the two.
Okay, I didn't really understand how to achieve this dependency injection, but I know where, I know what they're saying is where you don't achieve dependency injection. It's basically if one class is calling another class, like it's creating an object, it's using an object of another class, then there's a dependency between the two classes. And to reverse this, I don't really understand how to do it. So I know they create an interface, and then the interface kind of has to belong to the first class, and then the class that is implementing has to follow the interface defined in the first class. So, but then I don't know how do you really achieve the inversion of dependency in that.
So I think the important thing is ownership belongs to the higher level class, and then right.
Yeah, that's all I understood. But then I'm like, how does that really achieve that inversion of dependency? I don't know. And I know in Java and all they do it using a separate properties file that a object is defined there, so that if you're using the suppose the employee class is using or a college is using a student class, you say, and then so if you don't want to do if you don't want the programmer to be forced to define an object of the student class, then you give the student class in a properties file where the default values are there, right? That's what I mean. I'm thoroughly jumbled. I actually want you to explain how this works. I don't know.
Yeah. So what was your question again?
Like, I mean, either way, even if they say, okay, the interface has to be belonging to the higher level class, and then the implementing class has to follow the interface,
Yeah.
but still, I mean, you still need to create the object, right? So how is this inversion of?
What's a good simple example? of
Yeah,
actually
I couldn't
using it?
find
So
a.
the example in the article is the processing system versus the, I don't know, let's say the iMessage interface.
I kind of have the article. So yeah, it's okay. So what can you repeat the principle, the definition of the principle?
Yes.
Can you repeat the definition?
I can do that. So okay, so dependency inversion principle has two parts. The first one is high level modules should not depend on low level modules. Both should depend on abstractions. That's the first part. And the second is abstraction should not depend upon the details. Details should depend upon abstractions.
Yeah. And so
Yeah.
which principle is you have problem with?
I mean, how, like, theory wise it's fine, but you know, when it comes to implementation, like with the code, I'm not able to understand it.
What I don't understand is if it's implemented in the low level class,
Yeah.
what's the point? So this,
Implemented in a low level class.
so what's the dependency for the higher level class? Since the higher level class doesn't implement, right?
Yeah. Oh, yeah. So dependency should be on a higher level. You don't understand why, right?
Mm-hmm.
Yeah, because okay. So when you set up this, let me give you an example. Okay. So if we have like a university,
Mm-hmm.
like KSU, establish some sort of collaboration or dependency with another university. Maybe some program, we take half class here, and another half of the program class is provided by teachers from another institution.
Mhm.
Okay. So first, the KSU needs to establish some sort of a dependency relation with that university. Then, under KSU, all this college, all this department, they will start to implement this kind of connection. If that connection is not set up in the higher level, well, the lower level won't be able to have this kind of connection.
Mm-hmm. But that is just interface and the classes defining those interfaces, implementing those interfaces, right?
Yeah. So since the interface has all those connections,
Mm-hmm.
well,
So-
the classes that implement lower level classes that implement these interfaces,
Mm-hmm.
they automatically have these connections.
Yeah, but how is this dependency injection in this? Like, that is what it is about, right? They say it's reversing that dependency injection, right?
I think what that is trying to do is that you don't want to implement you don't want to make do some changes in the subclasses that will force the superclass to change.
Uh-huh.
I mean, it's
Right, you
like
don't
Yeah.
want to implement everything in the superclass.
no, you don't want to make changes in the subclass that is going to affect
Yeah.
the
So
superclass.
the superclass is kind of like a framework. We have a framework. We're working within this framework, doing this and that, some connections in between. And later on, we have a subclass. You decide, okay, I'm gonna make a connection with some of the other classes that's never been established the connection with. That may not be a good practice.
Mhm.
It's better to do that you need to define that connection first in the framework. You need to have a new framework. Okay? Like when we establish the partnership with maybe with CNN, okay? And then we send students there. And for internship program established by the school, okay? Later on, we may find that we need another company to work with us because we have a new program. Then at university level, they need to start that connection first, so that every program program that implement this connection, we have a kind of template to work on, and we can set up connection with them.
So where does the template come from? Does it come from the interface? Does it come from the high level class? Like, I don't see the point in doing this at all.
Yeah.
Like, I really like.
I mean,
outside of
it
the
was all
defining
fine even
interface.
without this topic. That's what I feel like. Okay, you have an interface, and you give the interface to the other classes which are which want to use your function, or is going to give you data. So you give an API or an interface, and they implement, like, they give you data in that particular format, right? That's the interface.
This is one piece of that story that I kind of really feel that what they're trying to explain there is already.
I know. And by the time I reached this part, I was like saturated. So
that's how I feel. It's already
All right,
there.
it's okay. Just keep that question. I can bring you a better example.
yeah, a code example would be good actually.
I can make some slides, show you some examples.
Yes,
Yes.
please.
Yeah, and the only thing that I saw that kind of clarified it for me in a way was that the processing class, which is the higher level class, owns that interface.
Yeah.
That's really the only difference I saw, because it doesn't have to own it.
Yeah.
But
Yeah, in that foo and
bar.
bar example, right? Like what you're saying, the foo and bar example, what's given in the document.
Right.
The bar, like they create the interface class, and interface belongs to foo.
And then bar
Yeah.
implements.
I can bring you some maybe understandable example.
Yes.
Okay. All right. So before we go, I'm gonna check the attendance.